My name is Gustavo Pazzi. I teach computer science and mathematics here in London. And again, right, every time that I teach about game development, every time that I teach about these ideas of animation, working with simulations, keyboard input, we have to touch these ideas of a game loop. As game developers, sometimes the game engine that we're working with, the game engine already provides a way and exposes a way for us to work with the game loop. Right? So I have a feeling that most students, we understand these ideas of frames per second, right? Most of the times we talk to each other and say, oh, my game is running at 30 frames per second, my game is running at 60 FPS, and we have this idea that things are happening in a loop, right? We have frame per frame, right? We need to give this idea of animation, right? We render things in this loop as fast as we can. I think this is okay, right? Most of us, we understand these things. And again, if you come from game development world, or if you ever kind of experienced a little bit of game development, the game engine that you use, right? If it is Unity 3D, if it is Unreal, Pico 8, if it is a processing of P5.js, you name it, right? Most of the time, the game engine that you're using, this framework that you're using, they will expose these important functions for us. Right, so I think it is no surprise that we have usually what we call a setup function that is going to be called once in the beginning of our game. So here you can go and you can position the game objects, at the start of your game. You can set up their color, their size. So this is the setup function. You're going to call it once at the beginning of your execution. And then we have these two super important functions, right? One is called update and one is called draw. Or sometimes, depending on the engine, you're going to call this one update and render, right? So update and render, the game engine that we use, usually they guarantee that these things are going to be called 60 times per second or 30 times per second, depending on the game engine, depending on the implementation that you do. But most of the times, the way that these things work under the hood, right, the mechanics of how we call these things 30 frames per second or 60 frames per second, the implementation details, they are hidden, right? The game engine exposes the function, but how we make sure that that function is called 30 frames per second, the mechanics of that is usually hidden from us. So what I want to do right now, this course is going to be a short course. We're going to open this black box and we're going to look at how does that thing really works, right? How do we make sure that update and draw are called 30 frames per second or 60 frames per second? How do we make sure as programmers, how do we really implement that? If you look at a very simple, if you kind of just see like a bird's eye view of this problem, this is kind of usually the skeleton of how we should approach things, right? So we have setup being called once, and then we have this very naive while loop. So while true, right? While forever, you do these three things. We do what I call the holy trinity of the game loop. So the holy trinity of game loop is while forever I process the input, right? So I have to check the keyboard keys, I have to check if the mouse is being controlled. So process input and then update and draw. So I need to do these three things every frame, right? Every little pass of my loop, I need to process the input to check if the user is kind of inputting something with the joystick or the keyboard. And then I read those inputs. And then based on those inputs, I update my game objects, right? So if the key was the arrow key, I have to go and change my game object's position in the update. And then draw, the only responsibility of the draw function or the render function is to go and draw things on the display, right? Go and paint the correct game objects in the positions that they are after they were updated. So it would be very easy to just say, this is the game loop, thank you very much, goodbye, but there are several other things that we have to think about, right? This while loop is very naive, right? So how do we make sure that if I have a fast computer and if you have a slower computer, how do I make sure that my gaming experience is the same as your gaming experience, right? This is very important for the game loop, right? I cannot just get away with the fact that you're going to have the enemies going really slow and then my enemies are going to be super fast and then I need to have more reflex and time to respond to change. So these things, how do I guarantee that things have this fixed time step for you and for me? We have to think about that. But in order to implement a game loop, we need to select some technology, right? We need to select a programming language, we need to select a way of seeing the results on the screen. And I chose to use a language called C, right? The motivations for choosing C is very simple, right? It doesn't have as much overhead as other languages, and by being very simple, very minimal, we can probably understand and port the source code to whatever language you want to use. So if you understand how to create a game loop in C, you will be able to create a game loop in JavaScript, Python, Ruby, you name it, right? But the whole point is, there is a little problem here that we need to tackle first. So we are going to work with C, but we do need to access some components of the hardware, right? So I want to be able to access the display set, and I want to be able to access the keyboard to get input from the user. So in order to get access to these hardware elements, right, the display, the keyboard, the mouse, the joystick, if it was 1980s, 1990s, it was very easy, right? To access the display driver, to put a pixel on the display, it was very easy. I can just go to there is a special RAM memory, right, that was mapped to the display, and I could just poke the little memory address, and then I would see that color being stimulated on the display. But that was a more civilized era, right, a civilized time. Nowadays, there is something here in the middle that is protecting the hardware. This thing in the middle is the operating system, right? So the operating system, Windows, macOS, Linux, FreeBSD, OpenBSD, whatever operating system that you're using, the operating system is here protecting the whole hardware for being misused. So there is this whole kind of layer here called the operating system that is preventing us to go directly and communicating with the display driver the way that we used to do. So what I'm gonna do is this. As a professor, I don't want to go and have 2 hours explaining to you how to do things, only how to open a window and display something using Windows. And then another section that is 2 more hours explaining all the 500 lines of code to access and display things using macOS. And then another 2 hours explaining Linux, and you get the idea, right? So what I want to do is this. In order for us to have this, let's say the 3 most popular kind of variants, right? macOS, Windows, and Linux or Unixes. I want to have just one source code, and I want to be able to have the same source code work for macOS, Windows, and Linux. So this thing right here, my operating system, I'm going to use a framework, I'm going to use a library called SDL. And SDL is this library that we're going to install, and we're going to use the SDL functions because SDL work as this bridge, right? So SDL, it is very smart, and it knows already if you are using macOS, it calls the correct macOS functions. If you're using Windows, it calls the correct Windows API functions to display things on the display. And if you're using Linux, it's going to use what we call the X system to go and create a window, display the pixels, color the correct pixels, and etc. So do you see? That is what I wanted, right? I want to use this bridge, this thing, because I want to create just one source code that works for everyone. So regardless of the operating system that you're using, all we have to do is use the SDL library. The SDL library knows how to communicate with the operating system that you're using, and we can use just one single source code that works for everyone, right? So the question is, how do we install the SDL library, and how do we start calling these functions of SDL in our C program, right? So in the next session, I'm going to break very quickly, explain how to install SDL using a Windows machine. I'm going to explain how to install SDL on a macOS machine and how to install SDL on a Linux distribution. Right, the distribution that I'm using right here is a Debian-based distribution. So this is going to work exactly the same for Ubuntu, Lubuntu, Mint, right? All these distributions that are based on the Debian one. If you are using something else like Linux, Arch, or Red Hat, or Fedora, and you're not sure exactly how to install SDL and the compilers under your distribution, just drop me a message and I will try to guide you and see what is the correct command that you use. Or even if you're using NetBSD, OpenBSD, FreeBSD, right? Any of these Unix variants as well. Right, so we are going to use a compiler called GCC, right? We are going to use the terminal, and GCC is this application that we're going to use to compile our C source code. In most Linux distros, GCC should be already installed, but if by any chance you try to use GCC and then Linux complains that says that it cannot find GCC, what we can do is sudo apt install. So we're going to use this tool called apt, which is this package manager of the Debian distribution, to go and download from a repository online and install GCC in our machine. The easiest way to install GCC and all these compiler tools that we need is something called build-essential. So if I just hit enter right here, the apt package manager will go fetch from the repository all these compiler and build tools, and it will just install in your machine. I am not going to install because I already have GCC installed, so I don't have to do this thing. So now that we have GCC installed, all that is left to do is for us to install that SDL library dependency. And under Linux is very easy. All I have to do is sudo apt install, and I just need to ask apt to install something from libsdl2, because it's the version 2 that we want, -dev. Right, so we want the library SDL, but also the development files for us to compile and use SDL with our C code. And once again, as soon as you hit enter here, apt will connect to the online repository and download all the libsdl files for us. And not just download the files, it will correctly go and install and put the files in the correct folders of the Linux operating system. So all we have to do is include SDL and start implementing our code. And if you are using a macOS system, it's also very easy to install the dependencies. You will see that under macOS, we already have, right, every distribution of macOS already has GCC there, right? It's actually an alias for a compiler called Clang under the hood, but you don't have to install anything. It is already there with you. The only thing we need to do is make sure that we have SDL installed and in the correct folders of the operating system. That is also very easy. All you have to do is use the brew package manager, that is the kind of standard package manager for macOS. So brew install SDL2. Hit enter, it will just ask you to confirm, say yes, and that's it, right? Painless, no more issues. That is all you have to do to install the SDL2 and the compilers under a macOS operating system. Right, so let's quickly go to my Windows machine, and then we can start downloading all the dependencies and everything that we need to do to work correctly under a Windows machine. So the first thing we're going to do is we're going to go to the Visual Studio official page, visualstudio.microsoft.com. So here we have a couple of options, and the one that we want right now is this one right here, right? We want the full IDE, the Visual Studio IDE. You can come down here and just select the correct one, which is, in our case, the community version, because this one is the free version and it has everything that we need to go and compile our project. Just click on this one, wait for it to download. And as you can see down here, I downloaded the whole installer. All we have to do is double click. This is a normal Windows installer. It's going to download, install all the dependencies. This might take a while, so I'm just going to fast forward the whole download and installation. So it's downloading everything, it's almost done. And this might take a while in your machine, but just hang in there. And here we are. This is the installer of the Visual Studio environment. I need you to select this option right here. I want to have the desktop development with C++, because this option right here is the one that installs the actual Microsoft Visual C++. Right, so just make sure that this is checked, and you can go ahead and finish the installation. Next, next, finish, and that's it. So as soon as we're done installing Visual Studio, we can go ahead, execute the Visual Studio. And in this window right here, just choose Create New Project. And our project is pretty simple, right? Let's just start an empty project. Click Next. Let's just give it a meaningful name, so my project. And you can just go ahead and call it anything you want. And this is the location where it's going to save the files. And this is my solution name. I'm fine with that. It's creating my project for me. And here we are. Right, so I have my Visual Studio project right here. I have my solution and my project configurations and file tree on the right. And here is where we can start our project. Right, so the first thing I'm going to do is I'm going to come here in our source files. I'm going to right-click, add a new item. I want to select, this is going to be a C++ file, but just to make sure that we have everything correct, I'm going to call this one main.c, right? Because this one is going to be a basic vanilla C code. So main.c, add. So let's just start adding a little code right here. Let's just say include standard io.h and just a basic main function. Right, so just make sure that you have this main function signature right here with those parameters, and just a very simple hello world, right? And return 0 just because. So I don't think there's anything simpler than this, just a basic simple C source code. So if I come here, save, and I build my project, you will see that here in the console, it's going to say rebuild, 1 succeeded, 0 failed, everything looks good. So our Visual C++ compiler is running correctly. And if you just want to write a basic C program, that is enough. But in our case, we need to install a library called SDL. And SDL does not come with the Visual C++ compiler. So we're going to have to go download this SDL library and set up our Visual Studio to correctly go and look in the correct folders of the operating system. Let's come here for a second. Let's minimize this window, open again our web browser, and let's visit what we call libsdl.org, which is the official page for the SDL library. What we really want right here is go to download. So let's select SDL 2.0. And right here I have a couple of options, right? The one that we want is the development libraries, which is separated by operating system. So the one that we really want is this one, right, for Windows. So do we want the Visual C++ 3264 bits, or do we want the MinGW version? I want the Visual C++ one. Just click this one, download the folder. This is going to be a zipped file, so let's just show this folder and minimize everything else. And right here, all I'm going to do is extract this thing. So let me just extract this to this folder. And this right here is the main folder that contains all the important files that I need for SDL to work on my operating system. Right? So this folder right here, what I'm going to do is I'm going to quickly come here, rename it to just be SDL2. I'm going to copy this folder, and we need to place this folder with all these important files in a place in our hard drive, correct? I don't want to just leave it sitting here inside downloads. I want to put in the correct folder in the operating system. So what I'm going to do is I'm going to keep it simple. I'm going to go to my C folder, right, my local disk C, and I'm going to paste it right here. So right here in my C folder, what I have now is I have an SDL2 folder that inside contains all these important files and folders. So I have include, I have lib, I have the docs. Here is where my SDL is going to reside. So we have to just go back to Visual Studio, and we have to tell Visual Studio where these files are, correct? Because if I come here and I just say, Visual Studio, I want to include SDL.h. Visual Studio is already complaining, right? It says, cannot open source file SDL.h. And Visual Studio is correct. We haven't told Visual Studio where to look for these header files. And this is exactly what we're going to fix right now. So I have to come here to my project, right-click, and we're going to go to the project properties. And this window right here is where we're going to start adding the correct directories and point to the correct folders in the operating system, where this project needs to go and search for these header files and these libraries. So first things first, we come here into this configuration properties inside Visual C++ directories. Inside the Visual C++ directories, we have something called include directories and library directories. So we need to add both include directory and library directories to add the correct SDL path now. So in the include directories, let me just come here and add one more. So let's edit this thing. So do you see I have already all these values? I want to include one more. So I click here on new line. I can click these three dots right here to select my folder that I want. And the question now is, what is the include folder that I want to add to my Visual Studio project? Well, I can just go to local C drive, open my SDL2 folder, and here I have this include folder. So I just select and select folder. It included here the C SDL2 / include. Perfect. This is done. So we have added one include directory, but we still need to add a library directory. And we're going to do exactly the same thing. I'm going to come here, edit, and I'm going to add a new line. And I'm going to go again to C SDL2, but now I have to choose the library, right? This lib folder. And the only difference here is I have to select either x64 or 86, right? So 64-bit or 32 bits. Both of them should be fine, but since I want to give compatibility to 32 bits as well, I'm going to select x86. I'm going to select this folder, and I am pretty much done with my VC++ directories here. So I added include directory and I added a library directory. So now, if I just hit OK right here, you will see that Visual Studio is already happy, right? It didn't complain anymore about my SDL.h. So it knows already where to look for these header files. And let's just try to add one very simple SDL function here, right? Which is called SDL init. And SDL init expects a couple of flags, so I'm just going to say SDL init everything. Semicolon. So this should be okay, right? If I save this thing and I just call this very basic SDL function to try to initialize everything. And when I say initialize, it's just trying to initialize the video display, it's going to initialize the keyboard and all these hardware components. So if I come here and I try to say save all and rebuild my solution, I have a problem. What I have right here is not a compiler error. It is what we call a linker error. Because as far as Visual Studio is concerned, everything is syntactically correct, but whenever we are trying to go and find the implementation of this function, it couldn't find anything. So the way that C and C++ programs work, and the way that we build these programs, is we have one stage which is the compilation phase, and then after we compile everything and everything is syntactically correct, we have to go to the linking stage. And the linking stage tried to find the implementation of these functions, and it basically couldn't find anything. And it is correct, right? We have to go and we have to also change the linker options. So we have to go again to my project, right-click, go to the properties, and do you see how we have something called linker here? So if I expand the linker, we're going to have to come here under linker, general, and one of the things that I do is I come here in the linker and I say additional library directories. So right here, I'm going to add a library directory as well. Same thing, edit, add a new line, and let's go to C SDL lib, and of course x86 in my case. Select the folder, OK, and besides adding a directory, I have to come here and add a new input to my linker, because I need to send as an input a new dependency. Right? So these additional dependencies inside the linker, I have to add one more lib file right here. So I have to come here, edit, and here all I have to do is add a couple of lib files to work as an input of our linker as well. So SDL2.lib, but also SDL2 main.lib. So SDL2.lib and SDL2 main.lib. These two files, I need to add them. And this is what Visual Studio needs in the linker process. Correct? So if I try to come here and build everything now, perfect. So rebuild all, 1 succeeded, 0 failed. We are in good shape. Right? And just a quick parenthesis, for SDL to work, it needs our main function to be exactly like this. Right? You need to have all these two parameters right here in the main function. That is a requirement for SDL to work under Windows. Okay, so I would expect that if I compile this thing right here and run, we would see no errors and we would see hello world. I come here and I run. Oops, project system error, right? The code execution could not proceed because SDL2.dll was not found. And Visual Studio is correct, right? We need to add this DLL, this dynamic linked library, with our project if we want to execute things. So let me just come back here. So what I usually do here is I come here, I open my file explorer, I go to local C drive, SDL2, and inside the lib folder, x86, I have SDL2.dll. I just usually copy this thing. And the easiest way that I find is I come here to my project, right click, open folder in File Explorer, and right here beside my main.c, inside this subfolders that I have, I'm just going to paste that file, that DLL, as a file inside my project folder. That is pretty much enough for us to come here. Let's just rebuild again, just in case. 1 succeeded, 0 failed, and if I run, I will see no errors and I will see hello world, right? Which is what we expected. So this is a good sign, right? This is the proof that we have SDL being correctly included, and we are able to call an SDL function inside our Visual Studio. And that's it. We are all set, right? It was a little bit of work, but we are all set to work with C SDL inside Visual Studio in our Windows machine. Great stuff. So I am in my home folder here, right? Let me just create a little directory here. mkdir, make directory, game. Very creative name for a folder. So let me just change directory to enter the game folder. So as soon as I enter the game folder, if I list things, I have nothing. I'm listing all the files, I have nothing inside this folder. It's an empty folder. And this is the folder that is going to contain our source code and everything we need to create our simulation of a game loop. So the first thing I want to do is I want to put all the source code inside a small folder. So I'm going to create another folder here, src, and inside src, I'm going to create our main.c, right? The main entry door for our program. So you can use any code editor that you want. I'm going to use a very simple code editor so I don't hide anything what's going on from you. I'm going to just use vim to enter the main.c program. So this screen right here is my code editor, right? It's just a blank canvas that we're going to start coding from scratch. You can be using things like Atom, Sublime, Visual Studio Code, Notepad++, whatever editor you want to use, it's all good. So let's just start slowly. Let's just see if things are being compiled correctly and we can run our program. So let me just include stdio.h, which is the standard input-output. I need this to display things on the console, get these default types of C. And every program in a C language, we have to start with a main function. I'm going to keep things simple, right? This is going to be very beginner-friendly. And by the end, maybe I will optimize a couple of things, right? In theory, every C program has only one main function, and I'm going to just return 0 from this function to tell the operating system that everything ended successfully. There are no errors in our program. But before I go, I'm just going to say printf. So printf is just this old school function that just displays something on the screen, and I'm going to printf game is running. Right, I'm going to add a little \n to force a line break at the end of this printf, and that's it. I just want to start from scratch so we learn how to compile and also run our program using the terminal. So let me just save this thing right here, go back to my shell prompt, and I want to compile that thing. Right, so for me to compile my main.c, what I'm going to do is this. I'm going to go up to my parent folder, so one folder up, and if I list these things, I have only my src, my source folder. So I'm going to invoke GCC, which is my C compiler from the GNU family. So GCC, this is the compiler that is going to transform that .c source code, that text, into actually an executable binary program, right, with ones and zero that the processor can understand, I can send some flags for the GCC compiler saying -std. So GCC, what is the standard of the C language that I'm going to use? Let's just say that I'm going to use the C99. And this is just because across the years, right, the C language was evolving, right? New things were added to the standard. So I'm just going to say, I am going to try to be faithful to the C99 standard because most compilers are okay with the C99. And I can actually add several other flags for the GCC, right? You will see that professional projects, they add several flags to the compiler just to make sure that we pull the correct triggers and we compile our project the way we exactly want. I think one of the most popular is the -w all, right, to just make sure that our program also displays the warning messages, not only errors, but warnings. And then after I just set these compiler flags, what I like doing is I like to tell the compiler what are the objects, what are the files that I want to compile. So in this case right here, I want to compile everything that is inside this folder, / inside the src subfolder, / everything, right, star.c. So all the C files inside the subfolder src from the current directory, these are the files that I want you to compile, right? These are the raw C files that I want to add. And since this program here is very basic, all that is left to do is for me to say -o. So what is the output? What is the object name that I want to create? What is the executable name that I want to create? Let's just say that I want to call this thing a game. So this is it, right? GCC-w all, the standard C99. So I'm going to compile everything that is inside the folder source that has the extension .c, and -o, what is the output of my executable, is called game. So hopefully, as we can see, no output is actually good news. So if I list my files, now I have two items, right? I still have my source folder, but I have this red thing that is the game. And if I list these things in long format, you will see that the game in the far left, it says rwx, r-x, r-x. That X character there tells me that game is an executable file. So being an executable file, I can do something like /game, right? I can ask Linux to execute the game file from this current folder. So current folder /game. I want to execute this thing. There we go. Game is running. So this is the proof that we compiled our program correctly and that we successfully executed our program, invoking it in the command line. Right, so these are the extreme basics. There's nothing extremely exciting going on here. But do you see this command right here that we executed? GCC-w all standard source -o game. I don't want to have to type this thing all the time that I have to compile my game. So what we will see is, instead of writing all these things, I want to take advantage of a tool called Make. And Make is also a tool from the GNU community. For Make to work, I need to have something called a Makefile in the directory that I have my project. So having this Makefile here, I have to edit. It's a simple text file. And this text file is going to have a couple of rules for us. So the first rule that I want to add in this Makefile is something called build. So build : and then I have to hit enter. And this is super important. For Makefiles to work, the indentation needs to be done with a tab character. So I'm going to have to manually add a tab character. And then inside this indentation, I'm going to write the rule. Right? What is the rule of the build command that you want? So the rule that I had before was GCC-w all - the standard is C99. I want to compile everything from the subfolder src that ends with a C extension. And the -o, the output object of this build command, is going to be game. So that's it. That is my build rule. But build rule is not the only one I can have. I can have something called run rule, right? So if I want to run my executable, I can put this rule right here, /game, right? That is what we need to call if we want to execute my game. So this is a very simple run rule, but if by any chance I have something else, right? If I have a couple of parameters, then I can just put them on the run rule and everything will be fine. And the last one I want to add is what I call my clean rule. And by clean, let me just tab. The clean is pretty much removing, I want to remove, delete, the game executable. So by executing make clean on the terminal, I just want to go remove that executable and just leave the source code, right? No executable, nothing else. I just want to go and remove the executable. So this is me creating 3 rules in my Makefile. If I come here and I save everything and I quit, the way we execute a Makefile is we say make and then space the name of the rule. So I could say make build, but if I just say make with no parameters, with no rule, make will execute the first rule. So if I just say make, I will execute the make build rule. So let's just see if this works. If I say make went there, looked at the build rule, executed at that line, gcc-wall standard-o game. And if I look here, I have now the Makefile, I have my executable game and still the folder src. And as you would expect, if I say make run, I execute my game, I see the output on the screen, game is running, I'm literally running my game executable and coming back to the prompt. And also if I say make clean, I have just now cleaned my project folder, just left the source code clean as it should be. Right, so this completes the first step of compiling a project using Makefiles to make our life a little bit easier. So now let's move to something more exciting, right? Let's learn how to go into the depths of actually creating a game loop in our C program. This is all we have so far, right? I have just one include, I'm just including one library called stdio, the header, int main, printf, and I'm just returning 0 to the operating system to tell Linux, everything finished correctly, right? This process ended fine. Besides the standard input-output, remember that our main goal is to add a window, right? We want to open a window, we want to be able to render things and display, and we learned that to use that, we need to use the power of the SDL library. So I'm going to include, in the moment that you went there and you said sudo apt install libsdl2-dev, as soon as you asked your package manager to install that library in your system, the package manager is smart and placed the correct files in folders of your Linux machine. So these special folders, they are the folders that C is going to look for whenever we add an include between these angle brackets like this. So I know that as soon as I install SDL2, inside this subfolder SDL2 / I have a file called sdl.h. Right, so I have a header file with all this SDL function definitions, SDL constants, everything that I need to use SDL here in the body of my C code. So all I have to do is include SDL2 / SDL.h, and hopefully C will be able to compile things for us. So including this thing right here, let me just delete this line, and I want to initialize my SDL window, right? That is the main thing that I want to do. The first thing I want to do is open a window, start this render instance so I can actually go and display my objects on the screen. So in order to do that, I'm just going to create a very simple function called initialize window. Right, so I'm invoking this function, and right about here, let me create a little void function called initialize window. This is pure C, right? So just to really make sure that this function does not receive any parameters, I'm going to put void here. You kind of don't have to, but since we're talking about pure C, whenever a function doesn't have anything here, in C, actually this function can receive multiple parameters. Right? So if I don't have anything, in C, a function like this is actually able to receive several parameters. So just to make sure that in my compile process, I specify that this thing does not have any parameters, I'm going to put a little void here. And then we start working with these SDL special functions. I can say SDL underscore init, a function to initialize SDL, and between the parentheses, I could specify what do you want to initialize? Do you want to initialize the graphics driver? Do you want to initialize the keyboard input? What is this thing that you want to initialize SDL with? Since I'm lazy and I want to pretty much initialize everything, I'm going to use a little constant that SDL provides, which is called SDL underscore init underscore everything. right? So if I just say SDL underscore init, and I pass the little constant SDL init everything, SDL will initialize all the sub-elements that I need to work with SDL in my device. SDL init, the function, and the constant SDL init everything, all these things are defined in the SDL.h header file, right, that we just included. That is why we are able to use and call these things. So if I just say SDL init everything, SDL will try to initialize things. But maybe something goes wrong. Maybe we don't have the X windows, or maybe we don't have the display set, you cannot find something. Maybe we are just running on pure console mode. So if something goes wrong, or in other words, if the return of this call is anything different than 0, right, and 0 is the value to represent OK, so if that call is anything different than 0, something bad happened. And if something bad happened, I want to, let's just call this fprintf, right, which is the actual raw function of the printf, and I want to pass what is the output that I want. I'm going to pass to the standard error output. So I'm going to printf to the standard error. I'm going to say error initializing SDL, right, and then \n, just a normal message, right? If something goes wrong, we can actually see on the screen what went wrong. And you know what I was thinking? I think that if by any chance something bad happens, or if we have an error, I'm going to return 0. So I think at the end of my initialize window, I will return 1, saying everything went OK, or return 0 if something went bad. So instead of returning void for this function here, I'm going to return an integer, an unsigned integer. But just for the sake of simplicity, I'm just going to use an int here. And just to make things a little bit more pretty, I don't want to return 0 or 1. So I'm going to come here at the top, and let me define that false, this constant here, is actually 0, and true is 1. Right? So I can come here and I can say return false, so something went bad, or return true at the end, right, if everything went fine. And you know what I'm going to do? You see these definitions that I have right here? I'm actually going to move these things to a separate file, right? I don't want to mix constants definitions with my actual code. So let me just open something called constants.h, right? And for you, it's basically just opening a new file in your text editor. And let me just paste these things right here. Cool, so now I have these things right here. And if I go back, all I have to do is include constants, right? The file that I have just created, the constants.h. But constants.h is not between angle brackets. It's not in any special folder, system folder. I actually want them from my current folder. So /constants.h. So these first two ones are these special system folders, right? They include the lib folders of my Linux system. And constants.h, no, constants.h is my sibling file in this current folder right here. Cool, so this is us initializing SDL, and if something goes wrong, we display a message and we return false. Before I return true, I want to create a window, this structure that I called an SDL window. So I can have an SDL window, a pointer, I can call this a window, and this is going to be equals to SDL underscore create window. And we're going to have several parameters here, right, to initialize my window. So I could just leave things right here. I could have my SDL window right here. But since I want to be able to access my SDL window maybe inside the main function, right, down here, I don't want to declare this SDL window just here. So I'm going to do something ugly, but I'm going to declare SDL window here as a global, and I'm just going to initialize it with null, right, with a null value. And here I don't have to declare again, I just have to use this global. So the window receives the return of the SDL create window from SDL. An SDL create window expects several parameters. The first parameter is usually the title of the window. So whenever you open a little window, what is the little title that you want at the top of the title bar? So we could pass a normal my title or something like that, But since I don't want to actually display any borders in my window, and you'll see that I don't like displaying the borders, I don't like displaying any decoration effect, and I'm not going to display the top title border, I'm just going to pass no here. So I'll pass no for the title. What is the second parameter that it expects? So now I have to pass what is the X and Y positions that I want my window to be placed, right? What is the position in the X, Y screen positions? So since things are going to get a little bit lengthy here, I'm going to pass these things. I'm going to put each one of the parameters in their own line. So the first one was the title. The second one is the X and Y position. So I could pretty much come here and I say, I want at position 200 in X and 400 in Y, if I want to hard code these things. But I know for a fact that SDL has a smarter way. So if I want to place things in the center of my screen, instead of passing a hard-coded value for X and Y, I can pass a little constant. That is SDL underscore window pos underscore centered. So this constant right here is smart enough. So when SDL create window receives this constant, it knows, it looks at the resolution, X and Y, width and height, and places the window in the exact center of the screen. And that is true for both X and Y. Right, so if I pass the same flag for X and Y, I'm going to center in the horizontal and also center in the vertical resolution on my screen. Cool, so passing X and Y, I'm telling it to be centered. And now I can pass what is the width and the height of my window that I want. So I can say, let's say that I want 800 by 600, right? 800 in width, 800 pixels, and 600 pixels in height. But even better, let me just come here and define 800 and also 600. Right, so let's just declare a couple of constants with these things, and window width, window height. So first parameter title, second parameter X, Y, width, height, and now I just have one more parameter, right, which is actually a series of flags that I want to pass. So right here in this fifth parameter, I can specify what are the flags that tell the decoration, the style, any properties of that window if I have one. And then I can pass several constants, right? SDL has a couple of constants that I want. I'm not going to put full screen. I'm not going to put anything like that. I'm just going to pass SDL window borderless. Right? Because as I mentioned, I don't like having any border decoration. I just want a blank screen on my windowing system. Cool, so now this is us asking for SDL to create a window. But as you know, this is not a perfect world. Something might go wrong, right? So maybe this SDL create window couldn't create a window. Maybe there was an error message that was not able to perform what we wanted. So I need to test if the return of this pointer to that struct window is null by any chance, right? So if by any chance not window, right? If something didn't go right, I'm going to do pretty much the same thing, right? printf, sending to the standard error buffer, error creating SDL window. And of course, return 0, right? Return 0 to that function to say something went wrong. So we're almost there. So Gustavo, is that it? We initialized SDL, we created a window. Are we ready to start rendering things? Not yet, right? We just have one more thing that SDL requires us to do. So after I called SDL init, after I called SDL create window, I need to create what SDL calls a renderer. Right? So I need this renderer that is going to be attached to this window that is going to actually render things for us. Render our game objects, render our particles, render our sprites, have a color buffer, whatever you want. Right? So I need to create this renderer. So we try to create a window, check if the window is okay. Now I have to create what I call an SDL renderer, which is also a pointer, and I'm going to call this the renderer. It is going to be equals to SDL create renderer, passing a couple of parameters that we're going to see what they are very soon. So the same way I had this global SDL window before, I'm going to put the SDL renderer as a global as well. So SDL renderer, right, this pointer to the renderer. And I'm going to start as well with null. Because right here, I'm going to ask SDL create renderer to initialize this thing, to create my renderer. So what are the parameters that SDL create renderer expects us to pass? So the first one is, what is the window structure that this renderer is going to be attached to? So, well, the window that I'm going to attach this render is the one that I just created before. So window, right? This struct that I had before. The second parameter is, what is the driver code? What is the display number that you want to execute, right? Let's say that maybe you have different drivers, you have different devices. So if I had different things, I could pass the code of my driver here. But again, since I'm lazy, and you will see most programmers do that, I'm just going to pass -1 to tell SDL, SDL, I don't care, just get the default. Get the default display driver that you have for this renderer. So -1 to get the default, I don't want to specify anything manually. And do we have any flags for these things? Do we have any special characteristics, any special flags for this renderer? Not really, I don't have anything. So I'm just going to pass 0 here, right? I don't want to specify anything special, any new different way of rendering, so just 0. So I try to create a renderer, but also if not render, standard error, creating SDL renderer, and return 0. And I think I forgot to close my double quotes. Yeah, here we are. And I just realized that I don't need to return 0 here, right? I can return false. I can return false, right? So if something went wrong, I return false, return false. And at the end, if I reach line 32 right here, if I was able to initialize SDL, if I was able to create a window and I didn't return false, if I was able to create a renderer and I didn't return false, if I reach line 32, then I can return true, meaning everything seems to be okay. I was able to create a window, I was able to create a renderer, get back to my function call, continue from there. So that should be it for us, right? I think that is enough for our initialize window. Okay, so this is where we are right now, right? If I look here in my constants.h, this is one file that have a couple of definitions, window width, window height. We are going to expand this very soon as our program grows. But if I come back here in my main.c, we have this initialization function, right? Initialize window. And this initialize window, we are not returning anything right now. We have to fix that, right? Because in reality, this function initialize window right here, it returns an int, right? So we are returning an int variable. Int because it is basically false or true, right? 0 or 1. So if we try to initialize SDL init and something goes wrong, we return false, we return 0. We have to also create a window. So if we try to create this window and something goes wrong, we return false. We try to initialize and create a renderer, right? And attach that renderer to that window that we just created. If something goes right, okay. If not, we return false. And at the end, if we didn't enter any one of these returns false, we can say, okay, everything seems to be okay, return true. So initialize window was successful. Right, so what I want to do right now is, I want to actually start writing the skeleton of a very basic, very naive game loop. So I think what we have to do right here is this. Here at the bottom, whenever I'm initializing my window, I want in my main function, I'm going to do this. I'm going to do while true, right? So while 1, so forever. What is the holy trinity of the game loop? I need to process every frame, process input, I need to update, and I need to render or draw, right? Depending on how you want to call these things. But these are the 3 main things that I want to do: process input, update, and render. And do you remember how we spoke about having also a setup function? And we agreed that setup function is not part of our game loop. It's just called once in the beginning of everything, right? So I call setup once to set up my whole environment, my game object positions, colors, do whatever I want to do in the setup, in the initialization of my game. And then I actually go and start looping everything frame by frame, right? I process input, I update, and I render. Next frame, process input, update, and render. Next frame, process input, update, and render. And this is, again, the idea of a game loop. So to make this work, I want to do a couple of things. So do you remember that initialize window actually returns true or false if everything went fine or not? So I am going to create something here called game is running. So I'm basically creating a new variable that returns if we were successful or not in creating a window. And I'm going to do something weird here. I'm going to say while game is running, I'm only going to be entered and I'm only going to be performing my while loop if the return of the game is running is true. And you know what? This game is running right here. I'm not going to declare it right here. I'm going to set game is running as a global, right? So I just have this global here. It's called game is running. I initialize it with false because here at the bottom, it will receive true or false depending if we were successful or not creating a window. So game is running receives whatever returns from initialize window. I start my setup, and then while game is running, I process input, update, and render. And then I actually have to have, I'm just going to go ahead and do this. I'm going to create a void process input, which is going to be my function that processes input. I'm going to create a void update that is going to be responsible for updating my game objects, and I'm going to create a void render that is going to render my game objects. Right, so having these three functions right here, I think what I wanted to point out is this. I want to add this game is running to the while loop because my idea is that eventually something inside process input will change the flag game is running to false. Let's say that if you press escape, right? If you go in process input and if the keyboard key is escape, then I would set game is running to false. And then game is running is going to come here, is going to be false, and then I'm going to break my while loop and then eventually finish my program. Right? So that is the kind of the magic here. I'm going to have while game is running, I will process input, update, and render. Process input, update, and render. But eventually, right, in one of the cases, I'm going to press, let's say, escape, or I'm going to do something in the keyboard that is going to be the flag to say, I want to close my game. I want to close my program. Then process input is going to change the flag game is running, and at the next set, whenever I go back to my test of the while loop, game is running is going to be false, and I'm going to break and then end my program. That is the whole idea behind kind of having this while game is running is here. So one thing that I will also have to do is, do you see how we are initializing our window? As soon as game is running becomes false, eventually, I have to, before I leave, we need to clean after ourselves. Right, so I'm going to call something destroy window. And this destroy window we have to create, right? It's a function that I want to create to go and destroy that SDL renderer, destroy the SDL window that we created. So let me just void destroy window. And this is actually pretty simple. SDL already exposes to us a couple of functions to help us do that. I have something called SDL destroy renderer. We just have to pass what is the render that I want to destroy. Well, since it is a global, I can just pass renderer. I can also pass SDL destroy window, and you see that I am destroying things in the reverse order that I created them. So I destroy my renderer, I destroy my window, passing the window, and then the last one is SDL underscore quit, which is almost the equivalent of the inverse of the SDL init. Right, so everything is being done in the reverse order that I did. I destroy my renderer, destroy my window, and I SDL quit. Cool, but we have to do a couple of other things here. So I have process input, update, and render. Let's think about input first, because I want to be able to quit my program, right, at a certain point. So the way SDL works with process input is it pulls the events, and we have to create this SDL event right here. Pay attention that this is not a pointer. It's just a normal raw struct. So SDL event, I'm going to call this event, and then I have to pass SDL pull event. I have to pass a reference to that little struct that I have. So this is what makes everything happen, right? I pull that event, then I pass a reference to that little event, SDL goes, pulls everything, reads the interruptions, reads the inputs, reads all the events that are happening in the keyboard, the mouse, and then all I have to do is I have to check what is the type of the event that was just pulled. So what we usually see programmers do is they use the switch statement, right, to just test. In this event struct, there is something called .type, right, that was modified here potentially by this pull event. So what is the type of that event? And then we have to start testing a couple of things. So case something, I will do this, right? Case something else, I will do something else. So the first test that I want to do is something called SDL quit. And you see that SDL is our friend, right? It already provides these constants for all these things that can be triggered by the pull event. And you might be asking, okay, what is this SDL quit? Is that the escape key that you said, Gustavo? Not really, right? SDL quit is the event that is triggered as the event that happens whenever you click the X button of the window. Whenever you have like an X button, you have the window and you have a little cross. If you click that X button, that is the SDL_quit event. You see, what we are doing here, nothing comes for free, right? We have to manipulate and handle everything that happens in our window. The X button does not come for free either. We have to go and we have to program what happens whenever we click the X button. So what happens when the user goes in the X button, or even, you know, how in the Windows platform you can say Alt F4 to close the window. So what happens when this event quit is triggered? Well, I can come here and I can say SDL quit is game running equals false. Correct? I need to go and change that little flag that controls the while loop right here. Game is running. Oops, it's game is running, not is game running. So game is running equals to false. Because as soon as I click the X button, I want this flag to become false, and then my while loop here at the bottom will stop looping, right? Because this is going to be false. Cool, so coming back to where we were. So if SDL quit, game is running is false, and of course, I need to break, right? Because we always need to break if we don't want the case statement to fall down here on the other ones. Cool, so that was one case, right? When I have SDL quit. But we spoke that that is not what we want. We want to also quit our program whenever we press the escape key. So I'm going to do a little test, right? So if it is not SDL quit, and if it is SDL key down, so if this is the type of the event, if it is a keyboard down, key down, then what do I want to do? Well, I have to test what is the key code of the key that was pressed. So if the event, and then I have a couple of important things. Inside the event, I have the key, and then inside the key, I have the key symbol, right? The key sim, and then I have the actual symbol, right? I have the number, the code of the key that was pressed. If that symbol is equals to SDL key underscore escape, do you see? SDL always exposes to us these friendly constants, right? I don't have to go and memorize the actual code of the escape. Everything is in a constant. So if this is true, game is running equals false again. And that was it, right? Just let me go back and break here to make sure that we break at the end. So this kind of summarizes my input for now, right? All I want to do is go and set my game is running to false. So we eventually come down here and we break our while loop. So process input is going to be the one responsible for changing this game is running to false, and then as soon as we come here, it breaks. Cool, and then I have update and I have render. I'm not going to worry too much with update and render right now. I'm just going to do and put a little to do here, right? So I have to do the update, and I also have to, I'm going to have to do the render functions right here. Cool, I like to just save everything. And then if I come here to my terminal, all I have to do is make, right? Let's see if we have any errors. Yes, we do. So the first thing, it is the first warning I can fix, right? I have the setup. Let me just quickly come here and just add a little void setup here. That also doesn't have anything for now. I'm just going to have a to do. Cool, but there are a couple of other things here, right? So let me just see something. So everything okay, make. Right, so this one is important. it says, linker command failed. Undefined symbols for architecture x86-64. SDL create renderer, not found, couldn't find. SDL create window. And what Make is telling, what GCC is telling me, is that it could not find the references to this thing. And this is because whenever we were compiling things, so let me just open my Makefile. In a C program, we actually have a couple of extra steps in the compilation, in the build process. We have a preprocessor that just goes and solves those hash defines, hash includes. Right? So the preprocessor goes and solves those things before we move to the compilation phase. So the compilation phase is the thing that checks if our program is syntactically correct. Right? It sees if everything makes sense, the return types are okay, if the function parameters are okay. So whenever we have here in our main.c, do you see how we have this stdio.h, sdl2/sdl.h? The compilation phase of the C only looks at the header files, but the header file only has the definitions, right? The signature of those functions. So we only know, for example, what is the return type, what is the type of the parameters, are the parameters in order? That is all the compiler needs to know to see if these things here make sense, if it can parse things correctly, right? But that doesn't mean that the C compiler knows the meatier part of what create renderer does, right, behind the scenes. So the body of these functions, we need an extra phase after the compilation phase called linker. So the linker is what goes and bundles things and goes and links all these libraries, all these files that belong to the libraries with their actual body, their actual implementation. So this is what we are missing, right? We are missing something in the linker phase. We had a linker error, not a compilation error. We had a linker error. The reason we had a linker error is we are using something called SDL, right? Which is this library that we are including. But right now we are saying GCC-warning all, right? I want to show all the warnings. I want to use this standard of the language. I want to get all these C files, and I want to create an object called game, a binary called game. We need to specify also what we call linker flags. So GCC knows also where are those libraries that we need to link against. So if I come here and before my object, I put -L SDL2. This is the linker flag for GCC to know that it has to go and it has to link against these libraries here of the system, SDL2. Right, so this is a linker flag that I'm sending, SDL2. I have a feeling that if I save this thing right here, and let me quit, and if I now try to make my project again, now we're talking. Right now I specify that I have that linker flag and I need to link against SDL. So right now, I think I should see something on the screen. If I say make run, we're going to go and try to create a window, try to create a renderer, try to pull the events of the system. And here we have our first SDL window running on the screen. It doesn't seem like much, right? But we are opening a window, we are attaching a renderer, we are doing everything. We are correctly linking again the SDL library. This is a big step. If you program in C code, you know that this is actually a huge deal. We got the whole override of compilation, linking against the libraries. So this thing is actually in a game loop, right? We have that while true, right? While game is running, loop, 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 loop. And one test that we could do is, are we actually polling the events of the input? Are we actually processing input? Well, one way to find out. If I press escape, I should close my window, destroy my window, and get back to my prompt. And exactly what we were expecting. Perfect. So here we are opening a window, creating a render, and also super important, processing the input, right? So we are checking if the symbol of the key press is escape. If that is escape, we change the flag to true. And then eventually this thing right here will become false, as we just saw. And we go and we destroy our window and we return 0 to the terminal. Cool. So we have a very simple process input running, right? But we still need to go and create update, create renderer, and we have a couple of other things to also talk about when it comes to game loop. Right now, if you look at the body of update and render, those things, they don't have anything, right? So we still need to think about actually going and rendering game objects, rendering my scene in my window. And that is what I want to focus quickly right now, this next part, this next lecture. So you see here we have this render here. I'm not going to do anything on update right now. I'm just going to focus on the render part. So what I want to do quickly is this. In the render part of our game, I can ask SDL to help me with at least the basic idea of drawing these pixels on my renderer. Right, so I have things like SDL set render draw color, and this is pretty much us saying what is the color that we want to activate right now to be used in the next draw command or draw instruction. So the first parameter, you'll see that usually we have to pass what is the actual renderer context that we're talking about. So renderer that we declare up there. Now I have the R, the G, and the B, right? The red, green, and blue components, and also what we call an alpha, the transparency. Right, so what is the R, the G, the B, and the alpha that I want? Let's just do a little test, right? Let's just say that I want 255, because the range is from 0 to 255, right? So I want to say 255 red, so full red, no green, no blue, but I want 255. I want no transparency, right? It's full opaque. I set the color that I want. I can call SDL render clear to go and clear my render context with the color that I just activated. And here is where we can start drawing our game objects. Right, so we clear, it's going to clear with red. I want to clear my render, and then here I'm free to go and do a while loop to go to all game objects, loop everything, render them. And here at the end, there's just one important thing that I have to point out. So SDL, it works with this idea of a double buffer technique when it comes to rendering. And when I say double buffer, think of two things. Think of a front buffer, which is the thing that is currently being shown to the user, right? The front face. So the front buffer is the thing that you are seeing as a user. And the back buffer is this buffer that we have the freedom to go and start populating, start rendering our game objects. This back buffer is hidden. And then when we are done populating and rendering everything in the back buffer, then we perform what we call a swap, right? And then we swap the buffers. And then we go with this hidden back buffer that was being rendered. We go and we just we render everything at once. The whole idea is you don't want things to be displayed in this kind of timeline effect, right? You don't want to start rendering things and then start showing the geometries and showing the game objects in this kind of flickery effect, with these artifacts, with glitches. You want things to be, if you can, you just render everything hidden in the back buffer and then you just show everything at once. Right, you just do this one operation of showing everything at once. That is this technique of trying to prevent this, this flickering, these artifacts of glitches and things to the user. So you just render things on this hidden back buffer, and then when you're done, you just swap the buffer. And then the back buffer becomes the front buffer, and then you start drawing things on the back buffer again, while the front buffer is being displayed. And then when you're done, you swap the buffers again. So this idea of swapping the buffer is what SDL calls SDL render present. And then we just have to say what is the render that I want to present. Right, so this whole idea of this SDL render present is what I call the swap, right? The buffer swap that we had. So as soon as I do this, the buffers go and the back buffer goes and is displayed as the front buffer, and then we have now the back buffer, then we can start rendering things again in our next frame. Cool. So now that we have this idea of back buffer, front buffer, and then we have this very small render function that so far is just setting a clear color and then presenter the render, swapping the buffers. Let's just see if we have something. Make. Aha, so in line 59, it looks like I forgot something, right? And I think I actually did. So right here, I need to say that I want to clear this renderer right here. Make again. Perfect. All good. So let's just see how this thing works. There we go. Oh, that's a horrible color, right? But we are successfully showing that we are rendering that thing with the color that we picked, the red. Cool. First of all, Let's really come here and let's just change this thing to 0. So let's just put a black background, clear everything with black, and right here I want to draw a rectangle. So one of the first things that I'm going to do is I want to say SDL rectangle, right? So this is a simple struct from SDL that just has the X and Y position and the width and the height of the rectangle, right? It's just this abstraction of a rectangle type. So let me call this ball. It's a rectangle, but I'm calling this a ball. And this is a simple struct. And in order to pass X, Y, width, and height, I want to come back here, up, and I want to create a little struct called ball. And this struct ball has a couple of options. So my ball has a float X, has a float Y, which is the X and Y positions in the screen that I want my ball. I also have a float width, and I have a float height. So a ball is basically a simple struct with 4 float values. And I want to go ahead and just say that this struct ball, I'm going to call it ball. Right? I'm going to already declare this little ball type. So perfect. If I go down here in my SDL rectangle, I want to do a couple of things. So in the setup, remember our setup function? I want to come here and I want to say ball.x equals to, let me start at 20 pixels, right? So ball.y equals to 20. These two things are actually floats, but I'm going to initialize them with 20. And then ball.width, let's just say that the width is 15, and ball.height is equal to 15 as well. Cool, so as soon as we set up our game, right, as soon as we initialize our game, these values are going to be set to the ball x, y, width, and height. And instead of x, y, width, and height here, I want to put ball.x, and let me just put everything in their line. So x, ball.y, this comes from ball.width, and this comes from ball.height. And that is our ball. And I'm going to call this one ball rectangle. Right, so this struct SDL rect, I'm going to call it ball rectangle. And the one thing I need to do to actually ask SDL to render this rectangle for me is called an SDL render fill rectangle, right? I want to draw a rectangle and fill it with a color. What is the render context that I want to draw? And what is the reference to the rectangle struct that I want to render? So ball rect. Right, which ball rect is this thing that I have just defined right here with x, y, width, and height. So SDL is going to go and it's going to render something for me. If I quickly come here, save, and make run. Right, so we are not seeing anything, and that is correct. Because remember how we set the draw color to black? We are clearing everything with black, and our rectangle is also being filled with black. So before I draw my rectangle here, I want to do an SDL set render draw color. So what color do I want to pass to my renderer now? Let's just draw this thing with white. So full red, full green, full blue, and full opacity, right? No transparency. Now I think, and now we see something going on there, right? So this is it. This is us rendering our first little game object on our screen, right? At position 2020, and then with width 15 and height 15. Okay, so now that we have this thing being displayed there, to make it move is actually pretty simple, right? I can just come here to my code and I can say, well, now in the update method, right? And since I have this global ball object, all I have to do is ball.x, let's just say that I want plus equals 1, and ball.y plus equals 1. Right, so in theory, I am incrementing 1 pixel to the right in x and 1 pixel down in y. So I assume I will see things moving down diagonally. And also, I just want to make sure that these things right here, since x, y, width, and height of the ball, they are floats, I just want to create a rectangle casting things to int, right? So let me just cast things to int, and this is just the pure C cast. And that should be okay, right? Since we are talking about pixels, there is no such thing as 20.5 pixels, right? So I'm just casting things to this nearest integer one. Cool, so let's just see if our update worked. Okay, I don't know if you noticed, but it moved, right? But it was really fast. So we do have some problems here that we need to fix. Coming back to my editor, I just want to point out a couple of things, because now we are reaching the actually important part, right? The core, the heart of our discussion on a game loop. So right now, remember that we have this very naive game loop, which is not actually a game loop, right? It's just this kind of eternal loop that says, while true, right? While this is true, process these things. So a while, right? This instruction, this C instruction, this statement, while loop, this thing is very linked, it's very tied to the idea of how fast the processor can go and compute all these instructions. Right, so this is, if you go and you convert these things into machine code, this is only going to say, while true, go and execute these instructions as fast as you can go, right? So this is going to be very tied to the idea of the clock, of how fast that processor can execute these instructions, one after the other. So that brings us to the point that if I have a slower machine, if the clock of my processor is slow, I am going to perform these things, this while loop, right? This step-by-step instructions, this program counter instructions on memory. These things are going to be executed slower than in your super amazing computer that is, this very fast frequency processor that you have. Then you're going to have, that is the point, you're going to have a different gaming experience than I would have in my processor. So this is the thing that we need to fix, right? I need to guarantee that your gaming experience is the same as my gaming experience, right? If I execute our little game in my slow computer, or if you execute this game in your computer. Again, it's not fair, right? If you go and execute this computer in my machine, it's slower, right? This while loop might take a lot of time to go and execute things. So the frames that I'm seeing on the screen, they are very slow. Then I see all the enemies coming. I have all the time in the world to go and respond, right? To react and, move right, move left, escape from the enemies. So it is not the same if you go and you execute this thing on your machine, which is going to perform this while loop super fast as it can. And then you have these enemies really fast, going a lot faster than mine, right? These enemies are coming in a really fast pace. And then you have an unfair gaming experience comparing to what I had. So we are going to have to fix this thing right here, right? We need to make sure that our game loop is fixed, has a fixed step. And you're going to see people talk a lot about this, fixing your time step of your game. Because I want to make sure that we have these ideas of, let's say that I want to execute things 30 frames per second for you and for me. I want to execute things 24 frames per second, 60 frames per second, right? So that is what we're going to have to achieve. We're going to have to pick how many frames per second we really want to present to our user, and we're going to have to do a couple of techniques. We're going to have to apply a couple of techniques with time step, delta time, because then we're going to have to work with these things frame by frame. Thinking about how do we go about defining frames per second? How do we go about defining and making sure that everyone that is playing our game really executes things 30, 60 frames per second? So we're going to learn how we're going to fix that time step, thinking about frames per second, thinking about what we want to achieve and how we want to display these things frame by frame to the user, right? So let's just quickly go back to our terminal, and I want to declare a couple of things here. Do you remember how we had the constants.h? So we have things like true or false, right, that we declare, and I think the main ones were window width and window height. I want to do a couple of things here. I want to define something called FPS, right, which is how many frames per second do I want my game to run. So let's just say that I want my game, right, since the human eye is kind of after 24 frames per second, our flawed eyes, right? The perception that we have, we perceive things as animation, right? Smooth animation. So I think we can really, like, if you look at the anatomy, we can look at things around 24, more than 24, we kind of perceive things as this smooth animation. So I'm going to put 30 frames per second, right? Let's just say that this is our target frames per second that we want to show our game. And then more than that, more than frames per second, I need to define something which is called, what is my target frame time? So in milliseconds, how much is each frame going to take? So let's just think about this. If I'm telling my FPS, my frames per second, that I want to display 30 frames per second, then do you agree that each one of those frames is going to be 1000 divided by 30, right? That means that each one of those frames, since I want 30 frames per second, each one of those frames is going to take 33.333 milliseconds, right? So 33.333 milliseconds is the target length of time that each one of those frames is going to take. I'm going to declare something called my frame target time. So frame target time is going to be 1000 divided by how many frames per second I have, right? Because it's not going to be always 30. I can come here and I can say 60 or something else, but in our case it's going to be 30, so our target time, our frame target time, how much I expect each frame duration to be, is going to be 1000 divided by how many frames per second I have. Cool, so now that I have these two things defined, the frames per second and my frame target time, I can just quickly save and go back to my editor, and let me just go up, and let me just quickly search for update here. Cool. So my update function, here is where I'm going to put the logic to keep a fixed timestamp, right? Because I think that the update function is the one that kind of ties with the idea of, the loop that I want. I just want to go and update my game object as soon as I reach that frame target time that I want, and then I can go and update things. So this is where I'm going to put the little logic for my update function. And I think everything starts with us thinking about what we call this delta time. So I know that I'm going to have to keep track of how much time or how many milliseconds elapsed since the last frame was updated and the current frame right now. So since I'm going to have to keep track of that, let me just go up, and I want to create a little small variable here that is going to be called int last frame time. Right, so this is going to keep track of the milliseconds of the last frame that I called. Let me just quickly go back again to update, and I'm going to do this. I'm going to call this last frame time, and there is a function called SDL get ticks. So this function SDL get ticks is super important for us. Do you remember when we called the first SDL init whenever we were trying to create our window? As soon as we start the SDL init, SDL keeps track of these ticks in milliseconds of how much time has passed since that init. So this last frame time is going to receive the SDL get ticks. So how many milliseconds have passed since the start of our SDL initialization? Cool. Having the last frame now correct, here is where I want to just delete this line. And right here, I want to now literally waste some time, right, or sleep, until we reach the frame target time, until we actually reach that amount of time that we know that each frame is going to take. So in order to do that, there is this thing called SDL delay, right, that helps us kind of go and ask for SDL to delay a couple of things. But just so we understand exactly what is going on, I want to force us to go and do things manually. So what I'm going to do is I'm going to put a while loop that is basically going to waste a couple of cycles. And this while loop here, I have a function in SDL that is called while SDL ticks passed, and then I pass the first parameter and the second parameter. And SDL ticks passed, it gets these two parameters and say, compare these 2 milliseconds and only return true when that time has actually passed, right? that amount of time really passed. So I want to compare the current time that I am and the current time I can get with the SDL get ticks. So compare the current time with the last frame time plus my frame target time, right? So compare the current ticks with the ticks of the last frame plus that target length that each frame needs to take. This thing is going to return true or false, and it's going to return true only if it passed. So while not SDL ticks passed, and look what I'm going to do. I'm going to go to the end, and I'm going to put a semicolon there at the end. Let's just look at this thing here. So what I'm doing is I have a while loop that the only purpose of this while loop is to lock my execution. I come here and I lock the execution, so I reach the update. I compare the current ticks with the last frame time plus the target, and while not ticks passed, so if I didn't reach that target frame, I'm going to lock, right? And it's just a while loop with a semicolon at the end. This is valid, right? It's just a while loop that is only going to go true, right? So while this thing is true, you lock the execution. As soon as you reach the target time, then you release the execution, and then you get the last frame time, and then you update your ball positions again, you update your game objects, you do everything, you render, and then you, next frame, you reach update again, and then you start everything again. If everything went really fast, you're going to have to go and come here and waste more time, wait. As soon as you reach the target time of the frame, you release the execution and update again. Come here, lock again, lock. As soon as you release and you reach the time, you update again. So do you see how I am forcing, right? I'm doing things manually here just to show you that this is just a simple while lock there, right? I can use the instructions of the machine to lock. Sleep this thing right here until we are ready to go and perform everything again. This is the guarantee that I am going to have 30 frames per second, and you, if you're running on a super fast, crazy supercomputer machine, then it doesn't matter. You're going to have 30 frames per second gaming experience, right? And then the game is going to be as juicy as it can, right? Then it's up to us as programmers to work with these frames per second to make the game, how they call juicier, right? Thinking about animations, thinking about frames, thinking about updating these things to make the gaming experience better for everyone. But this is us really making sure that we lock everything, and then we only release when we get our frames time. So I think, let me just put here, let me put 2 pixels, right? So we can actually see things moving. So if I save this thing, if I make no errors, and if I execute my game, okay, so now things are a little bit slow, right? I'm incrementing things 2 by 2 pixels, 30 frames per second. So that is exactly what we wanted to achieve. So perfect. Now that we fixed our time step, I want to look at this idea of changing the way we update game objects, positions, animations, to think about updating them as a function of what we call delta time. Right, so let me just discuss a little bit a couple of these ideas. So do you remember, right, whenever we were displaying and changing, right, changing how fast the ball moved in X and in Y, the first thing that we had was this idea of ball.x, right? The X component of my ball increments 1, and Y increments 1. So our idea was to go and change 1 pixel down, right? But I don't want to think about how many pixels I change in my game object. I don't want to think about how many pixels I change per frame. That is not how I want to think about how things update in my game, right? We usually want to think, instead of thinking how many pixels per frame I move, I usually have to think how many pixels per second, right? So I think that kind of makes more sense for us. So I want to make sure that my ball increments and moves 30 pixels in 1 second, right? And for me and for you, right? Regardless of the speed of our computers and etc., always going back to that idea of our fixed time step. So that is not how I want to think about things, right? So no, what I want to do is to fix this idea, we want to use this idea of using delta time as this factor that we're going to multiply, right? We're going to have this little factor that we're going to apply to our delta there, to our displacement, to fix this idea of how we approach thinking about this game loop movement of objects. So just so for us to understand these things, what I'm going to do is I want to get this thing called delta time, right? And delta time was exactly that thing. It's the difference in ticks, right, from the last frame that we have to the current one, but I want to convert to seconds, right? So look at that. I have float delta time, my variable, which is SDL get ticks, which is that function that gets me the current amount of milliseconds that elapsed since we started our game. So SDL get ticks, get me the current milliseconds, subtracting the last frame time. Remember that we do have a variable that we keep track of the last frame time, right? So the difference between the current from the previous one, and then since these things are going to give me everything in milliseconds, I kind of like converting them to seconds, right? So divided by 1000. So this delta time factor there is going to give me in seconds, right? In kind of seconds, it's almost going to be things like 0.00023 something, right? It's going to be a very small factor in some cases, a little bit bigger, a little bit less, but it's just a tiny factor because I want to use this thing as. The delta time is the amount elapsed since the last frame, converted to seconds, and we don't think how many pixels per frame, but then we shift our tackle and we tackle the idea of thinking how many pixels per second. Because this delta time is going to become a factor. Then I multiply to how many pixels per second I want. So this line right here is saying that move the ball 20 pixels per second to the right, right? Because we're incrementing 20. So I just want to point out that we have ball.x plus equals to 20, and that 20 is what I want to think of, right? 20 pixels per second. But then to make that per second, I have to multiply that 20 by this factor that I got, right? This delta time. So in this case, it's going to be something like, let's just kind of random, like 0.0236, right? So this very small delta time factor, I multiply by 20 because that is what's going to guarantee that I just increment a little bit in x, right, to actually go and reach that goal, which is thinking about my movement as pixels per second and not per frame. That is what makes us think about per second, right? And just to point out that now our game objects will move correctly regardless of the frame rate that we have, right? Always thinking about how much that object moves or what is the animation speed in frames per second, not in pixels per second, not pixels per frame. And also, as a rule, all objects in my scene, they should be updated, right? The enemies, pedals, all this terrain, if we have things going on. So all the objects in my scene, displacement, position, the speed, everything should be updated as a function of delta time, right? So my delta time will always accompany these things, and always I multiply by the little delta time factor to actually go and think about things, moving things per second, etc. So let's just quickly go to our editor, and I want to point out a couple of changes that we just have to go and do, right? We're going to probably create something called delta time here. That's going to receive a couple of things, and then we are going to multiply this ball.x plus equals 2 by the delta time to actually get this little factor and think about things moving pixels per second. Right, so let's just quickly understand how these things work. Remember that we have the delta time is going to be SDL get ticks, which is the current milliseconds that I am, minus the last frame time, which is the last milliseconds of the last frame. Right, so the difference between those, the current and the last one, and remember that I want to convert to .0f, right, to make sure that this is a float division and I get a float value out of it. So I'm just going to be a little bit verbose, and I'm going to say get a delta time factor converted to seconds to be used to update my objects later. And now that I have my delta time with this factor already, right, I can come here, and whenever I want to really go and update my object position, I don't think about how many pixels per frame I want to update. So let's just say that I want to update 50 pixels times delta time. 50 times delta time. Or let's just put some different, right? So it's 70 pixels in X per second and 50 pixels in Y down per second, right? That's why I'm multiplying by delta time. I think if I did not make any mistakes, I did not. So if I just run this thing, now we are definitely updating the position of our ball per second, right? In X and Y. And the movement, the speed of this movement is being calculated per second, right? Exactly how we want it. I'm guaranteeing that I'm going to the right 70 pixels each second and 50 pixels each second in Y. And the beautiful thing, if I come here and I want to say that now my game is actually 60 frames per second, we actually won't see much difference, right? But we are calculating a lot more frames per second. But the speed is pretty much still the same, right? We are updating in the same rate. If we kind of just look from a top view, it looks okay, right? It's very easy to understand a while loop locking our execution inside that little loop statement and then releasing once it's finished. The whole problem is the way that we're doing this is okay for us, is an academic exercise, so it's easy to understand that we're locking execution, but in the real world, you probably shouldn't use a while loop. While loops are processor instructions, meaning that once we compile our program, the little while loop will become part of our executable. And the operating system, whenever it's executing that task, it doesn't know if it should delegate the attention of the processor to other tasks or what it should do. So it's basically going to consume 100% of the CPU, of that CPU core, for our task, right? So our process, the little executable that we're running on the operating system, is probably going to burn a lot of the processor. And that is not what we want, right? I don't want to have my process wasting resources, 100% of the CPU getting 100% of the attention of the processor to just kind of be locked there doing nothing, right? There is nothing being done inside our while loop. So that is usually not how we're going to approach. So I'm just going to show that if I move here and I show this screen right here is the equivalent of the Windows Task Manager, right? So I can see the process, how much is using of memory, how much is using of CPU. So this little process that you're seeing here, this is our executable running. And it shows me in that little row, the memory percentage, the CPU percentage. So do you see how using a while loop, I am consuming virtually 100% of that CPU core? That is definitely bad news for us. That is not how we want to program things for real-world applications, right? Your process needs to share the CPU and share memory with other tasks, right? If you have Microsoft Word open, if you have your web browser open, these things need to kind of get attention from the CPU as well. So what I would suggest is, instead of using a while loop, and I know a while loop is very easy to reason about and think about locking the instructions there, but instead of using just a simple while loop, I would recommend us to use what we call a delay function, right? A proper delay function. And when I say a delay function, for example, SDL has this thing called SDL_delay, which is a function. And if you look at the documentation, this function right here, you call and you pass an integer, right? An unsigned integer, milliseconds. So how many milliseconds you want to sleep? You want to pause the execution of that process. And from a high level, you will probably think, okay, SDL delay, I pass how many milliseconds? How is it different from the while loop that we do, right? How smart is the SDelay function compared to a while loop? The thing is, a proper delay function, it relies on the operating system capability of yielding the execution to other processes. So we are not just locking the instructions inside a while loop. Whoever implemented SDL delay, right, the smart people that implemented SDL delay, they are using the operating system instructions to go and say, operating system, go and give attention to other processes, right? I'm done with these processes for this amount of milliseconds, and you can go and you can give attention to something else. So you go and you yield the attention to other processes. And when we reach those milliseconds, then we get back the attention, then we can perform the update, render, and etc. So a proper delay function is operating system specific, right? The operating system, the way it schedules the processes, the way that it manages the tasks, that is how a delay system should really work. It should rely on the operating system ability of going and giving the attention of the CPU to other processes of our operating system. So the summary of everything is, instead of using a while loop, I would encourage us to use something like an SDL delay, just passing how many milliseconds we want to sleep, right? But we know right now that this sleep means stop the execution of this process and give, right, and yield the process attention of the CPU to other processes of the operating system until we are ready to go and resume back our execution of our executable, right? So the way I would approach this is this. If I want to just replace my while loop that we have right now by an SDL delay, I will probably be looking at something like this. This is a very simple replacement of that while loop, but it does pretty much the same thing, right? So I am creating a little variable that is going to store frame by frame how many milliseconds I need to wait, right? So I have this time to wait variable that is going to store the target frame time, so how much each frame should take in milliseconds to run, minus the difference between the ticks now minus the milliseconds of the last frame. So this little time to wait variable is going to store how many milliseconds I should sleep until I'm ready to resume the execution again of my process. And I'm just doing a little if statement to protect. So if my time to wait is between 0 and the frame target time, so I'm just want to wait if my time to wait is between those values, meaning that we are too fast for that frame, right? So if we are too fast, I just do a raw SDL delay call, passing the time to wait, how many milliseconds I want to sleep. And that should do the trick, right? It's a very simple implementation. I just basically replace the logic by using an SDL delay. And if you look now to our process inspector, and if I filter again just to show my executable, look at the CPU percentage that it's consuming right now. It dropped significantly, right? So that is good news. So I would encourage you to, instead of using a while loop, maybe replace it by an SDL delay. I know an SDL delay is still a little black box for us, right? We don't understand exactly how it is implemented. But the problem is the implementation of the delay function. It is operating system specific. So SDL delay inside the internals of that function is probably going to have a couple of if statements to say, if it is Windows, you do this. If it is macOS, do this. If it is Unix, Linux, FreeBSD, do something else. Right? So operating system per operating system, we have a different way of delegating and resuming tasks and calling attention of the processor. So all these things, they are operating system specific. That is why I'm not going to open this black box and see the internals. I'm just going to say, SDL delay, take care of this for me, go sleep for how many milliseconds I want, and then give me back the execution whenever I'm ready. And that is how I'm going to approach this, right? So from now on, I think it's important for us to just use an SDL delay, right? So because we don't want to burn our CPU just with our task. Right? We should be respectful to other processes of the operating system as well. One thing that I want to point out, do you remember how we decided to cap our frame rate at 60 frames per second or 30 frames per second? So we wait, right? We have to wait a certain amount of time, those milliseconds, until we reach the target milliseconds of each frame, and then we release. Now that we are using the delta time factor to multiply and all these things kind of adjust the displacement correctly, there is no real requirement for us to cap our frame rate. So I could come here and basically just, I could come here and just bypass, right? I can say, I don't want to wait any of these things. So I just don't use the delay, I don't cap my frame rate. But the beauty is, since we are using delta time, it is okay, right? It is going to adjust. It doesn't matter if you are running our game at 800 frames per second or 1000 frames per second, right? Which is possible, right? We can go as fast as 1000, 1500 frames per second, depending on your machine. But since we have this delta time will assume a little value, right? A small value or a bigger value, and it will be okay. Even if we're running at 800 frames per second, the ball will correctly move at, let's say, 20 pixels per second or 50 pixels per second. The delta time will take care of that. So there is no real need, if you don't want, there is no need to go and cap the frame rate and wait for that time, right? Waste those times if you don't have to. You can just let your game run free at 800, 1000 frames per second, and you will see that some game engines actually do that, right? They just let the game run free, use all those processor resources, but then always adjust things by the delta time. Okay? So just wanted to open this parenthesis, make sure that we all understand this whole idea of capping frame rate, multiplying by delta time. Everything has a place, and you can choose to do something or not do something else depending on what you want your game to do. So all these things, I think they are really important for us to think about, and also, right, understand SDL, rendering things. As a suggestion, maybe you can go and actually move this ball around, right? Bounce on the borders. Maybe you can create a couple of pedals left and right. You know where I'm going with this, right? Maybe as a suggestion, as an exercise to this thing, create your own Pong version, right? Pedals up and down, and you can control with the process input, right? You have 2 players, you have the ball bouncing, and then you can go and you can really create this experience, the game, right? Using your own custom game loop that we created. All right, I want it to be something very quick, and this is something that we use a lot in other courses in our platform. So here you go, a healthy game loop, all built by hand, using C and SDL to our benefit.